So today is all about authentication and access control. So this is where we're going a lot more in depth about the specific security standards that we'll be covering for the Network Plus exam. So start off by talking just a little bit about filtering, what that is, talk about user accounts in a little bit, as well as user authentication methods. So right off the bat, it's important to understand the CIA triad. So these are the three goals of information security, and if you take me for security next semester, we'll certainly go a lot more in depth, but for now, just understand we're trying to maximize the confidentiality, the integrity, and the availability. So confidentiality states that the information is not accessible to people it should not be. That's not to be confused with it is accessible to people it should be. Okay? So being accessible is just, is it available or not? Availability is not concerned with whether or not the correct people can access it. It's concerned with whether or not it can be accessed at all. Okay, and then we also have integrity, making sure the information is correct. So it's kind of basically in networking terms, confidentiality, we're likely to achieve that via things like encryption, via things like secured standards, 802.1x. If we're using home networks, maybe we're using WPA2, or in 2021, maybe WPA3. I guess I shouldn't limit myself like the book does a couple times. Okay, integrity is making sure that the packets that we have are correct. Okay, do things like MD5 checksums, SHA-512 checksums. Okay, and then availability, making sure that we can access what we need to. Okay, but it's not just making sure that we can, it's making sure it's accessible at all. Does everyone understand the difference between confidentiality and availability? Okay, so availability is making sure something is up and active. Confidentiality is making sure that the wrong people cannot access it. So let me ask you this. Let's say that I were sneaky and I went behind your workstation, unplugged the Ethernet cable from it. Would that help or harm confidentiality? You could make an argument that it helps it, couldn't you? Sure. Integrity, is that going to affect it at all? Not likely. You can make somewhat of a case that it would, but we're not going to go too crazy. Like I said, this is more of a next semester topic. What about availability? That would be greatly affected, would it not? So that's the three triads. We'll cover that more. Okay, so access control list. This is basically a firewall. Some slight differences. It's going to be router-based as opposed to being a separate appliance. And basically what this does, this is going to tell what packets and what ports and everything like that are allowed. So it has some additional uses that firewalls don't necessarily have, but that's not entirely true. In fact, I would argue that a modern firewall is going to be a lot more robust than any access control list you could dream up. Okay, it's like another layer of security though. So we have a firewall. Why not do some stuff on the router as well? It's basically what this boils down to. So you can see here we have we have a public network here, private network here. What is this basically? What is this router basically acting as? Starts with a D. Basically a demilitarized zone. Okay, so we have different rules here. A can access B, but B cannot necessarily access A. Okay, the public network, and that's how you would want it basically. So pretty straightforward. Some basic things they can do, just like a firewall, it can deny requests. And I would say, unlike a firewall, the top rule for firewall, or the bottom rule, I should say, what's that going to be? It's going to be your implicit deny. Okay, it's going to be a little bit different with access control lists. Basically, it's going to deny stuff that wouldn't make sense to get through. So internal things, you're not going to send a MAC address out to the internet. That's just not going to happen. An APIPA address. Why would we not be sending an APIPA address across the network? What's the nature of an APIPA address? I mean, the whole point of it is it doesn't transmit across the network. Multicast is going to prevent that. Lots of good stuff. You can do basic MAC filtering. You can filter by port. Lots of things you can do with it. Like I said, just understand it's basically the same as a firewall. I would never ask you to distinguish the two because, well, they're basically the same. They do a lot of the same stuff. Okay? So we got tunneling, and basically tunneling is we want to have one type of packet transmission and want to do something else with it. That's it in a nutshell. So definition, generic term for encapsulating one transmission in another type. Like I said, you got one packet, maybe it's an IPv4 packet, maybe you want to use IPv6 on your network, so you put that entire IPv6 packet within the IPv4 packet. So some examples you may see, VPN, SSL, TLS, there's a lot of examples. And a lot of times you'll see this used for security. Doesn't have to be though. For example, is IPv6 more or less secure than IPv4? I think you can make a pretty strong argument it's actually less secure than IPv4. Who can tell me why? Okay, let me ask you this. Does IPv6 currently use anything like network address tunneling? So hypothetically, if you're using an IPv6 exclusive network, can anyone reach your system? Yeah. If you're using an exclusively IPv4 network, can anyone reach your system directly? Not directly. They have to go through your router. So I guess technically it still has to go through, but what I'm saying is IPv6, pretty much any address on that's going to be public. Does that make sense? Whereas with IPv4, you're sharing a public IP and you also have a private IP. So you can make an argument that it's less secure. That's one example where you're not using it for security. Okay, so you got two hosts here. They got routers on each side. You got the internet. Tunneling is going to establish not really a physical direct connection, but it's going to establish almost like a virtual direct connection between the two, if that's what it does. Okay, so one type of tunneling would be VPN. This is where you're basically having a LAN, two LANs communicating across a WAN. So what is the WAN going to be? Okay, it's always going to be the internet, or I shouldn't say always, but almost every time it'll be the internet. Okay, so you have different LANs. Like I say, you've got your host over here, got your host over here connected to an office. They're not going to run a cable all the way from his Colorado home to his Dallas office, are they? Okay, that wouldn't make sense to do. So instead, you're going to use a virtual private network. Okay, so that would be an example of client to site, where you have one device connecting to a corporate office. Host to host would be two machines connecting directly to each other. It's common in servers, where you have one server having a direct connection to another server. I wouldn't even say common, but it happens. Okay, site to site. This would happen if you have, let's say, multiple different campuses separated by a geographic area. So let's use an example. Say Target. Okay, you guys know Target? So Target, do they have just one location? No, they have many locations. So if they wanted to have all those locations connected together on the same network, are they going to want to run cables to every location? Not physically. That's not really feasible to do. So instead, they can use a site-to-site, where each of the different sites are connected. That way, everything across the LAN is actually across the WAN. Does that make sense? Okay, extranet. It's going to be where you wanted to have a VPN that would have limited access, because extra means what? It means outside. Okay, so it's an organization outside your organization, but they're probably related in some way. Think about an economic cartel. Okay, you guys know OPEC? Okay, so OPEC has an extranet, and that's one of the ways that the companies involved in OPEC and countries as well are able to share information. Okay, now I'm not here to debate whether economic cartels are good or bad. Obviously, what do they violate? They violate free market assumptions. So whether you think that's good or bad is up to you. From a business standpoint and from a consumer standpoint, it's not really fair competition. That's certainly a true statement. But that's outside the scope of this class. Okay, so SSL. I don't know why the book talks about this instead of TLS, but hey, whatever. It's where you have HTTPS, although in modern time, what should you be using instead of SSL? TLS. Okay, so they're both going to be asymmetric encryption. They both work pretty similarly, but TLS is going to be a lot more up to date and support a lot better encryption. It's going to be faster. No real reason to use SSL. So what happens is, of course, you send a connection request, and it's going to send you its requirements, and then you establish the connection. Okay. SSL VPN, I just put up here it exists. There's really no reason to use it over IPSec. I don't know why it's really mentioned in the book as much as it is, but just understand it exists, but IPSec is better in almost every circumstance. Okay, so DLTS is going to be where we focus on data-specific protection. So mostly that's going to sort of make sure that our packets aren't being intercepted and manipulated in any way during transmission. It's going to be very important, because imagine we're transmitting credit card numbers. Number one, do we want those credit card numbers to be intercepted? Number two, do we want them to be changed? DLTS. Okay, that's really all you need to know about it. It's a layer 2 tunneling protocol. This is going to be a protocol for tunneling. It doesn't have inherent security built in, but it's at layer 2. So because it's at layer 2, it means it supports many different protocols. So hypothetically, you could encapsulate different layers, and certainly do lots of transmission across TCP/IP that are not TCP/IP. So there's some obvious benefits there. Okay, point-to-point tunneling protocol, completely obsolete. Okay, almost no reason you'd use it in 2021. Because like I said, IPSec is better, it's faster, it's more secure. So basically, what this is going to do is have point-to-point protocol. It's going to combine that with general encapsulation protocol, which we'll talk about in the next slide. And one of the main downsides to this is it opens up 2 connections. So instead of supporting one connection, you're supporting a point-to-point session and a generic routing protocol session. Does that sound like a good idea? No, it's not a good idea. Okay? Well, it may have been a good idea for the time, but in present time, it's just not a good idea. IPSec is better in every way. I don't know why you would ever use point-to-point. All right, any questions so far? Okay, generic routing encapsulation. Like I say, this doesn't provide any enhanced security or anything. It's at layer 3, whereas some of the other stuff's at layer 2. It's completely stateless, no flow control. Really, all you're doing is you're taking a tunnel that's going to allow you to encapsulate any layer 3 standard, or most layer 3 protocols you would imagine. So it's going to have a lot of overhead, 24 bytes in the header for each packet. And you can imagine, if you have a lot of packets, there's going to be a lot of overhead. It's going to be a fair bit. So this is what it looks like. You have your transport IP header, then you have a GRE header after that. Okay, and then you have your actual packet. So no built-in encryption of this, like I said, is just to allow sort of additional functionality. Okay, IPSec. This is an important one. It's at layer 3, and it's going to be the standard for most things tunneling related. Not everything. Because, for example, if you're using HTTPS in 2021, what standard are you hopefully using? Hopefully you're using TLS. So it's going to be the standard for most things, though. Basically, what it has is an authentication header. And what that does is that sort of is like a checksum where it's going to verify that the packet is not altered in any way. And that can be purposeful altering, accidental altering. Then you have your encapsulating security payload. Obviously, that's going to be the encrypted contents. So this is what the process looks like here. Standard packet just has your payload, your header. You've seen a packet. Basically, what this does, this encrypts that information. Okay, so that's what IPSec is. Any questions about it? And you can apply different encryption to it. Like I say, we're not going to cover that too much this semester. It's more of a next semester topic. Just understand it. So, speaking of encryption, 2 major types: symmetric, asymmetric. With symmetric encryption, you have a single key to both encrypt and decrypt. Asymmetric, you have 2 keys. Most of the time, it's going to function as a public and private key, where the public key is given out freely, and you can encrypt anything you want with it. To decrypt it, you use the private key. Common example of this is PGP, pretty good privacy. It's going to be for email encryption. Sort of an older standard, but it still works. So not really any major problems with it. That's basically encryption as far as we're going to go. Remote access, obviously as the name would imply, you're not on premises. So you're going to be accessing some sort of resources, be it a network, be it a computer, a server, something like that off-site. Okay, so a couple different things to know. RDP, it's going to be a Windows proprietary standard, but it's most of what you'll see, because what do 90% of corporations use almost exclusively? Windows. Why do they not use Mac? Why don't they use Linux? Well, a couple reasons. Number one, familiarity. But bigger than that is, how do you manage a Mac device? How do you manage a Linux device? You can make an argument that you could use some sort of a third-party solution. You know, for example, what's the famous example of that for the device manager for Mac? I can't think of it right now. It'll come to me later today. But, you know, there's several examples of those. And same thing with like a lot of mobile devices. Okay? You could use a mobile device manager. But, of course, with Microsoft, what do they have? They have Windows Server. Okay, Windows Server lets you do pretty much anything you could imagine. At least in terms of managing devices, making sure that we have pretty good standards for all the devices on there. You know, group policy, Active Directory. Just not really a suitable equivalent, in my opinion at least, on Mac. Okay, like I said, there are device managers that will do a lot of the same functionality, but it's a lot better to be built into the OS. Okay, and I'm not here to say that Windows is the best operating system ever. Obviously, I don't believe that, but you know, what do 70% of servers run? Exactly. So it's not unsuitable for any enterprise use. It's just unsuitable for an end user device. Or I should say an end computing device. Okay, and that's an opinion, but can you name one corporation that primarily uses Linux for their end user devices? You can make an argument for Lowe's, possibly. A lot of their point of sale systems run a Linux variant, but it's not really common. Okay, so RDP, pretty much what you wouldn't want to use. And now the book, like I say, uses some outdated stuff talking about it. Fairly robust encryption. What standard do you think it uses? UDP or TCP? It's going to use UDP. Okay. So Independent Computing Archive, it's going to be a Citrix technology. Basically, it's going to be Citrix's protocol to host applications remotely. SSH is another important one to know. So obviously, SSH is going to be a telnet replacement. It's going to be using encryption on top of basically on top of a telnet connection. It's going to allow us to connect to remote devices pretty easily. One thing I'll say about it is, it's generally recommended that you don't use a password and you instead use a certificate. It's going to be a lot more secure, because how long is your password realistically going to be? You're going to have a 128 character password? I didn't think so. Okay, certificates are going to be a lot more secure. Managing user accounts. The book goes into a bunch of stuff about this. Just automate everything, okay? Your company's going to have some way that they onboard employees. Usually it's going to be through HR. Why on earth would you collect the same information multiple times? Okay, there's no reason to. It doesn't make business sense. Do we want to make business sense in here? Yeah, we do. Okay? You never want to say you don't want to make business sense in a course in the School of Business, now do you? Okay? So, automation could do things like create a user account. Someone changes their name. Maybe they get married. Maybe they get divorced. What other reasons may people change their name? Maybe they got tired of their old one. I don't know. Automate that. You don't want to manually make those changes. It's a pain. Okay, not only is it a pain, it's expensive. You got 100,000 accounts you're managing. Do you want to pay people to manage them? Who would want to pay someone 70 grand to manage accounts? And by the way, 100,000 accounts, you'd be having more than one person, probably a team of about 10 to 20. Okay, so 70 times 10, 700,000. 70 times 20 is 1.4 million. Or you could automate it. Okay, probably cost you 50 grand one time, maybe like 10 grand in maintenance. Does it not make a lot more sense to automate? Okay, like I said, I don't know what the book is going into about all this different stuff. You're going to have some way. Why not just have it be one form, does everything? Okay, the book suggests that you limit activity. For example, you wouldn't let a user use a device certain hours. Maybe you would limit how many connections they can have at once, how many times they can be logged in. I would argue that's not really the best option. Maybe you'd have, you can't have more than 5 simultaneous connections, but, what about having 2? Do you think I'm logged in multiple places right now? Yeah, of course I am. Okay? So, like I said, don't necessarily take the book as the right answer. It's going to be organization specific. Could there be some cases where you would only need someone to be logged in one place? Yeah. But is that true for every organization? Okay? Let's say that we're an accounting firm, and we have 100 accountants working for us. Each accountant has their own desktop. They have their own office. They don't really leave and go sign in somewhere else. Then would it make sense to limit connections a little bit more heavily? Probably would. Here's another point I'm going to disagree with the book about. They suggest you change the default administrative username on whatever system you're using. So if you're using Windows, don't use admin or administrator. Okay. I think that's ridiculous. Okay, so in my opinion, obfuscation is not security. So, I don't want to even bother with that. Why make it harder on everyone in your organization? Just use other technologies to prevent people from accessing your system without authorization. Okay, fail to ban. Okay, it's a great technology where basically on a certain amount of connection attempts, it's going to not allow them to have any more connection attempts for some set window. Firewall. If you don't have a firewall in place, then what is your organization doing? Firewall is, of course, very important, and you have a lot of connection requests coming in from, say, a Chinese IP address. Okay? Why would you continually allow them to submit those connection requests? Why not just block them? Okay? Does that make sense? Multi-factor authentication. Let's say our password is breached. Okay? With multi-factor authentication, there's still like a 1 in 1 million chance they're able to get into your account. Okay, I'll take those odds. So it's going to be a lot better than having obfuscation. That makes sense? So, and these are just some examples of what you would use. You would use many more. Okay, but, to say that you should change your default administrative account, that's ridiculous. Okay? That's some 1990s advice right there. 2021, it's not going to be effective. Okay? Are any of these things going to be 100% effective by themselves? No. But if you can get 99.999% effective with all of them, and you combine them, of course you multiply those together, you're going to have a pretty secure network, would you not? Okay? So like I say, obfuscation is just ridiculous. I don't even know why it's mentioned. Okay, passwords, just be reasonable with it. Length, types of characters. Make your own mind up about that. IEEE recommends at least 8 with 3 different types of characters as a default requirement. I would probably say for 2021, why not go for 10 or 12 characters minimum? So multi-factor authentication. Like I said, the book goes into this big deal about how you should have a 30 or 45-day password expiration policy. It's ridiculous. Okay? What happens if you make people reset their password every 30 days? Are you going to remember something you have to reset every 30 days? What are you going to do? You're going to write it down. Okay? So, password expiration, I use a no emoji or the stop emoji. Okay? We don't want to do it. What do we want to do instead? Well, we want to be proactive. We want to have Multi-factor authentication, so when you sign onto your account, you have to verify that it's you. Okay? You can do that a lot of different ways. You can use a phone app. Google has their authenticator, of course. I'm not endorsing Google by any stretch. Duo has a really commonly used authentication app. There's a lot of them. You could also use a physical token. For example, if you're in the military, what do? You get a CAP card. Okay? It's a physical token. Let's say you are in a private sector. Obviously, you don't get a CAP card. You may get something, what is it called? YubiKey? Is that it? I'm pretty sure that's what it is. It's like a token that you plug in, and then you're able to sign in. Okay? You could also, of course, use biometrics. Again, have your own opinion whether or not you think biometrics are an invasion of privacy. But, is it common to use a fingerprint to sign on? Okay? Think about if you use an Apple device, or I should say, I think only iOS devices currently have this, although Apple event coming up today, who knows if that'll change. Do they use facial ID, facial recognition? Okay? Yeah, they call it Face ID. So, I would say password expiration is just ridiculous. Okay? Anyone disagree with me on that? Who thinks multi-factor is better than password expiration? Okay? Most of you, that's good. And like I say, I don't normally submit an opinion, but I don't really know how you could argue that password expiration is a better policy. Does that make sense? Because let's say a password is breached. Okay, first of all, can we use technologies to determine if the password was breached? Yeah, we can. Okay, I'm not going to cover that too much in here. Just understand it's possible. Okay, and it's pretty easy. Okay, what's the website? Have I been pwned? Is that it? Yeah, check it out sometime. You can tell if an account's been compromised. So that's rule number one against it. I wouldn't say rule. That's fact number one against it. Fact number two. Let's say it were compromised, and it's compromised the day the user changes it. Okay? Then for 30 days or 45 days or 90 days or whatever your policy is, people can access that account. So, you're going to have a breach open for 90 days? You see the problem with password expiration? Okay. Multi-factor, far superior in every way. Automatic account lockouts. Again, I think that's both good and bad. Let's say that your administrative account is locked out. You can't access it for 24 hours because you had some chucklehead who tried the password 5 times. Okay, is that good? No, that's not good. Okay, what does that affect on the CIA triad? Availability, that's exactly right. Okay, so it's okay. What will be better than that is fail to ban. Okay, because fail to ban doesn't ban the account, it bans the person trying to access the account. Does that make sense? Single sign-on, yeah, it's going to be a good thing. You shouldn't have 50 different accounts for one organization. It's just going to be a pain to remember and pain to work with. Why not just have one account for the organization? And by one account, I mean one account per person. I don't mean one account for the entire organization. Okay, so certificates are going to be used to verify the identity. It's going to be an encrypted, not really a document, but an encrypted string. It's going to allow us to make sure something's legitimate. 2 common examples, certificate authority. Of course, that's going to be on a device. You have different certificate authorities installed. And it's going to be purposes to verify certificates. So for example, if you're using TLS, HTTPS, you're going to have certificates associated with that. Okay. And the other examples are like email and document signatures. A common standard is SMIME. It's somewhat proprietary, but not entirely proprietary either. Basically, it's going to have not a signature like you think of where you sign it. It's going to be verifying the email actually came from who it said it did. Because let's face it, just like a phone number, if you're sending stuff out via, say, POP, does it verify that you actually have access to that address? Is it possible to spoof that? Yeah. Same thing if you're calling someone on the phone. Can you spoof a caller ID number? Quite easily. Is that good or bad? Well, that's an opinion question. I think for most people they would say it's a bad thing. but it's legacy. So Let's Encrypt will allow you to create certificates. It's free. If you had a website, you could create your certificate via the website, and that'd be a good way to save some money. Could you also pay to have, let's say, a TLS certificate created? Yeah, you could. Pay me $20, I'll go on Let's Encrypt and do it for free. How about that? That wouldn't be very nice of me, would it? I wouldn't actually do that. I would just say go to Let's Encrypt and figure it out. Okay. So you have Radius. Talked about Radius last class. Remote authentication dial-in user service. It's the IEEE 802.1x standard. And basically what this does is this allows you to use your user account for your organization to access a network, be it a wired network or a wireless network. You can tie into AD or LDAP, whichever one your organization is using. Of course, obviously, you can authenticate via your organizational username and password. Okay, CHAP. This is a challenge handshake authentication protocol. It's basically obsolete because it's a shared secret-based authentication. So first of all, what's the major downside of shared secret? Okay, you got an untrusted device. Are you gonna trust them with whatever secret you have? Okay, let's say that I walked up to you on the street and I said, "Got any good secrets?" Okay, and you didn't know who I was. You gonna give me your good secrets? No, you wouldn't. The major downside of this. So I don't really know why I'm talking about it as much as I am. But basically what happens is you have a logon request, the challenge is sent, that's where you get the shared secret. It's going to encrypt it, it's going to give it to there, it's going to decrypt it, and it's going to give you authorization or not. Okay? That makes sense? So, really self-explanatory. Major downsides though. Okay? EAP. So basically we have PPP, which is of course talking about the point-to-point protocol. Okay, this is an extension of that. And basically what this is it's going to allow us to use not just one factor for authentication, but multiple factors. So not just using a password, but maybe a password and a hardware device. Maybe a password and biometrics. Okay, that's all the AP is. Used pretty commonly in enterprise networks. You may see this used with something like protected EAP, which is not in this chapter, but it's in the previous chapter. So it's even better, but still somewhat commonly used. Hashes, really straightforward. What we do is we basically take them, apply an algorithm to them, and it's going to give us some hashed output. Okay, it's going to allow us to verify the integrity of the data was not compromised, so it wasn't modified in any way. You have MD5 and SHA. Those are both commonly used hashing algorithms. If you download an operating system, let's say you're downloading a Linux distro, it's going to give you both of those. Most likely it'll give you either SHA-256 or SHA-512. And you're then able to, once you've downloaded it, to check the checksum of the data, make sure that it wasn't compromised. It's used in a lot of other things as well. Most of the time this happens automatically. Okay? And when I say it happens automatically, I don't mean when you download something from the internet, it automatically checks that. That's not what I mean at all. What I mean is that if you have a system in place, it's when it have checksumming taking place to make sure nothing is altered. Does that make sense? So it's a system doing it, not necessarily the individual all the time. Okay. Network access control. Some different things we'll talk about. Posture assessment. This is where you basically ensure that the device that you're on is compliant with whatever standards you're using for your organization. So let's say you require that they have all their Windows updates done. Okay, that's done in the posture assessment. Let's say you require that Windows devices have an antivirus. It's going to be done in posture assessment. Now I'm saying Windows here for a couple of reasons. The main one is that, are there really antivirus applications for non-Windows operating systems? I mean, they exist. Are they any good? So for example, ClamAV on Linux. Is it looking for Linux viruses or is it looking for Windows viruses? Yeah, funnily enough, it's looking for Windows viruses, mostly. Mostly what you do on Linux to avoid viruses is not be an idiot, okay? What I mean by that is you don't want to run some curled text, okay? If you start to see curl, you should probably back out because you don't necessarily know what the code is doing, okay? Avoid the common problems on Linux, like RMRF. Probably want to avoid using that. Not always, though. It can be useful. Just make sure you have the correct directory specified, not your home directory. Does that make sense? Okay. That's all in the posture assessment. Like I said, it's mostly a Windows thing because other operating systems, I wouldn't say they don't have that problem. I mean, there's certainly going to be, whether or not you classify it as malware is questionable, but there's certainly going to be, say, spyware on Mac. Okay. Certainly going to be spyware on the Play Store. Okay. But having said that, is that as big of a problem as all the stuff that you can do with a Windows virus? Or Windows malware, I should say. We'll talk about that next semester. Guest network. Obviously, you want to segregate stuff as much as, well, let me rephrase that. Obviously, you want to segregate your network as much as possible. Yeah, I'm going to make sure I don't give myself in too much trouble there. So yeah, you have guest devices. Those aren't corporate-owned devices. Do you want those to be able to interface with your corporate servers, for instance? No, not directly. That's what a guest network would do. It's going to be on a separate VLAN, obviously separate collision domain. Yeah, it's going to be completely separated off. It's going to be on a completely different subnet, VLAN, everything. And it's going to allow different policies to be applied to it. So for example, do you think it makes sense to limit your guest network to like 1/4 to 1/10 of your actual bandwidth you have? Yeah. Would it make sense to limit each connection on your guest network to, say, a reasonable amount of bandwidth? It makes sense to do that as well. Because what's the problem if you don't do that? You got a wide open network, anyone can join it. Then you won't have enough bandwidth left for your actual corporate functions. Does that make sense? So again, segmentation, very important on networking. Captive portal, so it's going to be a website where you typically just agree to terms. Sometimes you input a password. If you go to like a hotel, you've probably seen one of these, where you have to navigate to some address to get to it. And once you put in the password, it'll let you on the network. But the thing is with these is that you're technically already on the network. Because to get to that point, where do you have to be? You have to be on the network. So again, the book says this is a great thing to use. I disagree. I think it's pretty poor security, to be honest with you. Let's say your guest network uses a captive portal. Okay, you're trying to keep bad actors off the guest network. Well, guess what? You have the captive portal. That means the guest network is open for them to be able to get to it in the first place. Does that make sense? So, I mean, they're used in hotels. They're used in some other industries pretty commonly. I just think they're bad security practice. Does that make sense? Okay, and lastly, got a quarantine network. It's going to be if you had a device that did not meet your posture assessment, you put it on the quarantine network. It's going to be a separate network. And, I'm sure we've heard too much about quarantines the past couple of years. But basically, this is where you separate the device out. So if it has an infection, if it doesn't meet your criteria, it's not able to interface with your internal network. So that's basically what we want to talk about. Talk about security filtering, a little bit about user account management. We also talked about user authentication. So any questions about today? All right, guys. Hope you all have a great day. I will see you all Wednesday. Is it Monday?